Hello guys, hope you are doing well. You are preparing for the exams. So here I have taken the examples of IUPAC nomenclature, which we have discussed previously, and we have written word root plus 1 degree suffix, and second is 2 degree suffix, and on the left hand side 1 degree prefix and second degree prefix. I have taken the example of this one. This is the benzene thing. Okay, we will name start numbering from here: 1, 2, 3, 4, 5, 6. Okay, there are two groups are there, chloro, and one is the methyl groups there. So 1, 4, 1 position, and fourth position there are two dichloro, and the second position 2 methyl, and this is the benzene, and this is will be the name of this structure. Second one, this is the structure. So we will numbering from here because bromo and chloro are there. So B is the first alphabet. So 1, 2, 3, 4, 5. 2 bromo, 4 chloro, pentane. The word root carbon chain is pentane. Okay. Now let me take you further. This is the example. This is longest chain 1, 2, and 3. Okay. In second position, there are two methyl groups are there. So two position are there two, and one chloro, one position there is chloro, 2 dimethyl. There is 3 carbon prop and single bond is N. Now let me discuss about the nature of CX bond. So we know that electronegativity of halogen is more than carbon. So it attracts the shared pair of electron towards itself. So it is more electronegative than carbon. Okay, so it contains the partial negative charge, and carbon will contain partial positive charge. Because the bond do not break, that's why it is known as partial. Okay, so we will discuss about CCl, CF, BR, CBr, and CI. Take example of methane, CH3H. We will remove one H and we will add one halogen. Then it will be CH3X. X here is will be ClBrFi. Okay. Next, let me discuss about the bond length of order of bond length. We know that fluorine, chlorine, bromine, and iodine. As we move downward, number of size increases. Fluorine has a smaller size, and iodine has the bigger than all of them. Because number of shells increases, size also increases. So bond length is what that it is the distance between the nucleus of two atoms. Suppose this is carbon and this is halogen. Okay, so this is we can take this is fluorine, so it is small. Distance between it is the bond length. So the smallest bond length will be in the fluorine, and the highest bond length will be in the iodine. Okay, and next is the bond dissociation energy. What we can say about how much energy it will take to break the bond. So bond between carbon and fluorine is the smallest in size, bond is the smallest, so we have to give more highest energy to it to break the bond than to Cl, then to Br, and then to I. Okay. Next, about dipole moment, that is the important part. Dipole moment is represented by mu, that is the charge and distance. Okay. You know that going down the group, distance also increases. Okay. So the charge is only the electronegativity. It is dipole moment is directly proportional to electronegativity. So the highest electronegativity contains fluorine, then of chlorine, then bromine, then iodine. Okay, we are taking the electronegativity concept because distance is taken in the picometer. We can neglect this because it is a small option. Okay, so this option will be this fluorine. First of all, fluorine, then chlorine, then bromine, then iodine. Okay, but here there is an exception because we know chlorine is more bigger than fluorine. then the electron gain enthalpy of chlorine is high, so it can gain more electron than fluorine. So it will be the first chlorine, fluorine, bromine, and iodine. Okay. Next, I am discussing about the preparation of haloalkane, RX. First method, it is by hydrocarbons, RH. In this, first is there by alkane, free radical substitution reaction. I will only discuss one method, and another method we will discuss in the further videos. This process is known as halogenation. Okay. So let me take RH. Okay. We will react with 2 chlorine and it will take in the presence of light. 1 chlorine will replace the hydrogen and it will be RCl, and plus HCl will be the product. This is the haloalkane. We will get the haloalkane. We have to remember that it will take place in the presence of light, and high temperature will be also there. High temperature. Okay. So this is the reaction. Now let me take an example of methane, CS3H. It will react with chlorine. 2 chlorine are there. Okay. It will take place in the presence of light. It will take place in presence of light, so it means that the reaction will be continue. It will not stop. It will further continue. Okay, the 1 chlorine will replace hydrogen, then the product will be CH3Cl plus HCl. Okay, it will not stop here. It will again react with Cl2. Then the product will be CH2Cl2 plus HCl. It will not stop here also. In the presence of Cl2, it again react. Then we will subtract 1 hydrogen also. Then the product will be Cl2 plus HCl. Okay. Then it goes further. Cl2 in the presence of Cl2. Then CCl3 plus HCl. Then it will again react with Cl2. Then